Yeah. We start now?
Yeah.
Good morning. Good morning and good afternoon, our chief guest, our guest speakers, dear members, friends from the industry. Mr. Rajesh, Managing Director, VDMA India, and a co-moderator. A hearty welcome to all of you in today's webinar on the world of photonics, technology solutions from Germany, organized by VDMA India in association with VDMA members GMG MORI and 𝐏𝐡𝐨𝐿. We hope all of you and your families and employees are all safe and doing well. I'm Sandeep Roy, based out of the Kolkata office of VDMA, and we will be taking you through the initial part, also little in between also today's webinar. But before we enter the main phase of the web seminar, a brief introduction on VDMA. VDMA is the largest industrial association of Germany with plant and machinery manufacturers in the whole of Europe. Established around 130 years back, with more than 3,400 members at present, with over 1 million employees. VDMA caters to 36 specialized sectors under mechanical engineering. Our members produce machinery worth euro 205 billion, and out of that export 79% in 2020. Friends, sensing the potential of the BRIC countries in the early 90s, VDMA established its first foreign offices in India, followed by China, Brazil, and Russia. It has also offices in Brussels for coordination in European Union, an office in Japan for the Far East operation, Poland and Austria in Europe, and a recent office in USA. Before we continue, we would like to remind all of you that you can post all your questions in the chat box, and they will be answered during the question and answer session. Now I would like to invite Mr. Nath for his welcome address. Over to you, Mr. Nath.
Yeah, good morning, good afternoon, members and friends from the industry. Good morning to our members who have joined from Germany. Hearty welcome to all of you for this international web seminar on a very progressive and industry-oriented topic, World of Photonics, Technology Solutions from Germany. I extend a warm welcome to our chief guest today, Mr. Seenivasan Balasubramanian, Chief Executive Officer, International Aerospace Manufacturing Private Limited. Hearty welcome to you, Mr. Seenivasan, and thank you for joining us for this web seminar today. Also, a warm welcome to our speakers today, Mr. Markus Baeumler, Sales Director, LASERTEC, DMG MORI, and Mr. Mounesh, Product Manager, 𝐓𝐞𝐜𝐧𝐿. Friends, Einstein laid the foundations for the laser technology in his groundbreaking article, The Quantum Theory of Radiation. It was published way back in 1917. After years of development, the first widely commercialized lasers hit the market in the 1960s, when they were used for applications ranging from science to surgery. Since these early days, the unique ability of lasers to create a narrow, focused beam of light has enabled many other applications. In fact, in one of the most novel applications, the NASA rover Curiosity used laser-enabled equipment to blast rocks on Mars, allowing scientists to analyze chemicals in the resulting vapors. The laser market has steadily increased since the 1970s. The sector may now be on the cusp of a new age of innovation, in which lasers are increasingly combined with optics and sensors to enable even more sophisticated applications. In fact, the integration among lasers, sensors, and optics is becoming increasingly important for creating value in the next generation systems. For instance, the need for effective integration and real-time monitoring is likely to increase the importance of software in this traditionally hardware-driven industry. As OEMs across market segments increasingly turn to photonic systems to address customer needs, the lines between component suppliers, subsystem providers, and device integrators will probably continue to blur. Although the speed of innovation in laser technology may have been dropping slightly, the creation of integrated devices combining lasers, sensors, and optics could usher in a new age of opportunity. Companies that develop such devices now could have a first mover advantage, since end customers are likely to seek strategic partnerships to explore new applications and build product offerings. Photonics as a key enabling technology has the potential to facilitate the transformation process in collaboration with other technological disciplines for 5 megatrends in the future: industrial automation, growing connectivity, sustainability and climate protection, demographic changes, and healthcare. In fact, friends, the global photonic industry is expected to touch a value of 650 billion euros in 2023. Friends, wishing everyone an interesting and enriching web seminar today, and looking forward to the address of our chief guest now. Before that, I would briefly like to introduce Mr. Seenivasan Balasubramanian. Mr. Seenivasan, he's mechanical engineer with a post-graduation in manufacturing management from BITS Pilani, and he has done executive postgraduate diploma in business management from Symbiosis International University. He has around 2.5 decades of professional experience and is now working with Rolls-Royce as Chief Executive Officer of IAMPL, a joint venture between Rolls-Royce and HAL in Bangalore. So pleasure and honor for us to have you with you joining today, Mr. Seenivasan, for this important web seminar. and we are looking forward to your address. Thank you.
Thank you, Mr. Rajesh. Always a pleasure to be associated with VDMA. Thank you again. Good morning, good afternoon, friends. Also, good morning, Markus, for joining us from Germany. And good afternoon, Mr. Mounesh.
Good afternoon, sir.
And good afternoon, all the members who have joined this webinar. It's indeed my pleasure to be again addressing as to give an opening address for this upcoming and future of another technology area like photonics. And just before I introduce photonics, I remember photonics whenever we talk about photonics or laser. I go back to my childhood days where we used to play with a glass in our hand and how to divert the sunlight and then burn the paper by focusing convert the sunlight into a kind of a ray, sharp ray, and focus it and then burn the piece of paper, or even show it a wooden plank and then create fire in that. Or else we used to play the games like talking to each other at a distance during the childhood days. So those are all the things what we remember before we talk about the real technology of photonics, what it is today, and unbelievably, its contribution to the engineering technology today is unbelievable, and the future is we are depending on photonics for a lot more support to innovate the future products to serve our customers better and better. So, the photonics, the term came into wider existence since 1960s with the invention of laser and laser. After that, the laser diode. The photonics is to describe the field of light where it is used to perform functions accomplished with electronics. So that's the definition. But of course, when I talk about the application of photonics starting from the industry where I am, like the laser melting or the laser machining or the laser measurement, and to the telecommunications, which all of us know day-to-day use, where we use, and also it's widely used in the space, plus also on our livelihoods of agriculture, very widely used in agriculture today. The laser leveling of the field, it helps us to kind of conserve the water, which is another most important aspect of our future. To conserve water. The photonics, the technology is helping us to level the field in such a way that the water neither gets clogged or kind of neither wasted too much or used a little bit. So it kind of helps us to use the right amount of water to cultivate the crops in an effective way. Also, the technology coupled with the latest drones helps us to, with the technology, it helps us to understand the protein levels, the content in the wheat, to help the farmers to improve the quality of whatever they are doing, whatever they cultivate today, and which means like it's creating a healthier world. So as we know, this is something which I wanted to tell you, because not only that we are going to talk about the laser machining or the laser measurement, but it's also helping the livelihoods. Making more food available. Helping more agriculture, so that it helps the future generations better and better. So that's that's the contribution of photonics in our day-to-day life. Coming back to where we are where I am from the aviation industry, just to tell you, it's helping, of course, in the manufacturing. Apart from that, whenever you travel in the aircrafts, you'd have seen a lot of from the heads-up displays, whatever you see the pilot is operating, or the fiber optic networks, which we don't see in the back end. Photonics helps a lot more ways in the aircraft. In the monitoring and also in the maintenance. That's very lot more effective in the maintenance also. And probably if you have traveled in the Boeing 747, the 787 Dreamliner, you have seen the LED lighting and the electrochromatic, dimming of the windows, which used to be mechanical previously. It's this technology that helps us to now use that using the photonics technology, it's automatically adjusted. So that's the thing what we see in the aviation industry today, and it's particularly precision wherever now today in our industry. Precision is the word which is connected with the aerospace industry, and that to improve that performance higher and higher and meet the customer expectations, we look forward to the photonic technology to help us in terms of metal cutting or in terms of melting or in terms of the measurements. They help us to improve the accuracy of manufacturing in the aerospace industry. So anyway, we have Mr. Baeumler and Mr. Mounesh going to help us understand better on those areas. So without wasting further time, I thank VDMA once again for organizing this webinar, which is very important for the future of the industry. With that, over to you, Mr. Rajesh. Thank you.